In this video, I'm going to go over graphing lines and finding x-intercepts from the equation that you were given. Now, first of all, I'm going to do it the long way, and then I'll show you the quick way to graph lines. Now, we all know this form of y equals mx plus b, right? And m is our slope and b is our y-intercept, right? So if b is our y-intercept, then we have a point on our graph already, right? Because if x is 0, I'll put the 0 here, then it would be negative 1/3 times 0 minus 2. Anything times 0 is 0, so 0 minus 2 is negative 2. So y would be negative 2. And there is our y-intercept. All right, got 1 point. Now we just need 2 more points, let's say. Okay? Why don't we do negative 3 and positive 3? Why 3? Because I'm looking at this slope here, and I notice I have to multiply this number by that slope right off the bat. And if we're multiplying by 1/3, it's going to be easier if the number I'm using is a multiple of 3, because then I'm just dividing it by 3, right? So let's, negative 1/3 times negative 3 minus 2. Well, 3 divided by 3, right? So that cancels out. We just have 1. Negative times negative is a positive, so it's just positive 1 minus 2, which is not negative 7, negative 1, right? That was easy. What about positive 3? Okay, negative 1/3 positive 3 minus 2. Well, same thing, right? Except now it's a negative times a positive, which just leaves it as negative. So then we end up with negative 3, right? Negative 1 minus 2, negative 3. Okay, and that's plenty. I mean, we don't really need much more than that, right? But let's say someone asks for the x-intercept. Well, how do we find the x-intercept? Instead of plugging in numbers for x, because, I mean, that's our input, right? We just choose our input and we see what we get out of it, right? That's what we usually do. But when we find the x-intercept, we kind of flip things around. We say y equals 0. Why y equals 0? Because we're talking about where the line intercepts the x-axis, right? And on the x-axis, y is always 0 throughout. You know, if it goes up a little bit, it's positive. If it goes down a little bit, it's negative. But 0 is always the x-intercept, or x-axis line. So we say, what if our output was 0? Well, then how do we find what our input is? We do that time-honored tradition of solving for x. Add 2 to both sides, right? Negative 1/3, not 3. Negative 1/3 x equals positive 2. Now, how do we get the x by itself? We multiply by the reciprocal, right? And whatever you do to one side of the equation, you do the other. So we end up with x, right? Because 3's cancel. Once again, negative times a negative is a positive, so it's positive x. Negative 3 times 2 is negative 6. And that's how you find the x-intercept for any equation, any function. That's how you find the x-intercept. You set y equals 0 and you solve for x. That's why they teach you factoring, because when you have x squared plus 3x plus 7 equals 0, you got to factor that to figure out the different values for x, because there could be two of them. But this is a little side note. All right, so let's graph this. Let's see. Let's start with the x-intercept. -6. 1, 2, 3, 4, 5. Oh, I didn't go far enough. 6. -6, 0. So right there. 3, -3. 1, 2, 3. 1, 2, 3. Okay. 0, -2. And -3, -1. It's not a very steep line, is it? That's close enough. Not a very steep line at all. That's a terrible drawing by me. Close enough, though. Just make sure the dots are visible. There you have it. That is the surefire way. The just plugging in values and graphing those points and then connecting them. I'm going to show you the faster way. All right, in this part of the video, I'm going to show you the quick way to do it and demonstrate parallel and perpendicular lines while I'm at it. All right, first of all, let's start with this green function, f of x, 3x plus 2. Well, we have the slope and we have the y-intercept right there. Okay, y-intercept. We know where that is, right? That would be at 0, positive 2. So 0, 1, 2. Right there. Okay. Now, how do we graph this quickly? Slope is 3, right? Rise over run. It's positive, so we know it's going up as we go from left to right. And we know the rise is 3 and the run is 1. Right? There's an understood 1 underneath that. So rise 1, 2, 3 over 1. Boom. 1, 2, 3 over 1. Boom. Need another spot there. Now, as we go to the other side, it also goes down 3 over 1, right? Which makes sense when you think about it. 1, 2, 3. But instead of going to the right one, we're going to the left one because it's positive, right? Got to make sure that it's still going in the same direction. All right. Right about there, maybe? Yeah. Yeah, maybe a little to the left here. There we go. As always, my drawing is perfection. So there's our green line. That didn't take very long, did it? All right, let's do the red one. H of x equals 3x minus 6. Minus 6. 1, 2, 3, 4, 5, 6, right? Bang. Slope is 3. It's the same as the green one we just did. 1, 2, 3 over 1. 1, 2, 3 over 1. Hey, there's our x-intercept right there. 1, 2, 3 over 1. 1, 2, 3 over 1. Can also go down 3 over 1. Hey, I didn't make it through math class because of my great drawing skills. Now, you can't tell from these really bad drawing, but these two lines, because they have the same slope, will go on forever and never touch each other. There'll always be this distance between us. It's very sad. But that is what makes them parallel, right? Because slope equals slope. Their slope is the same. I don't know what slope equals slope is supposed to mean, but yeah. All right, let's do the blue one. 2/3 x minus 4. Okay, 1, 2, 3, 4. We got this down now, right? 2 over 3. So rise over run. So still positive. So we go up 2 and to the right 3. 1, 2, 3. Up 2. 1, 2, 3. Up 2, 2, 3. Or still in the positive direction, we go down 2, left 3. Right about there, right? Right about there. Okay. All right. So there's our blue line. Man, we can graph these real fast, can't we? All right. -3/2 minus 6. It's very different, right? So 1, 2, 3, 4, 5, 6. Start there. Okay. All right, this time our slope is negative, so we're going to be going down. So, -3 over 2. So we go down 3, 1, 2, 3, and to the right 2. 1, 2. It's kind of the opposite of what we were doing before. So going up 3 and right 2. We go down 3, then right. Right? It's you can remember it by remembering that in this quadrant here, we call this quadrant 1, all the x values are positive and the y values are positive. Whenever you put a point, but over here in quadrant 2, the x values are negative, but the y values are still positive. And here in quadrant 3, x values are still negative, but now the y values are also negative. That's why we went down and left, because left is negative x and down is negative y. And for this one, now we're in the positive x, but still negative y. Down is always negative y, and right is always positive x. That's how I think of rise over run. Just always remember, if it's negative, it's going downward as we go from left to right. And that's how you count your rise and your run, okay? But if you want an explanation for it, that's quadrant 1, 2, 3, and 4. Anyway, Let's grab some more points on this line and finish this. Finish this once and for all. Rise is 3, run is 2, right? 1, 2, 3, 1, 2. Okay. 1, 2, 3, 1, 2. Get so many points out of doing this. Let me just do one more. All right. Okay, so if these are parallel, what is this? Because they definitely intersect, but if my drawing was better, it would find these intersect at an exact right angle, 90 degrees. Why is that? Because their slopes are opposite reciprocals of themselves. What? Opposite reciprocals. Negative reciprocal. For something to be intersecting at an exact angle of 90 degrees, it has to be going the opposite. It has to be decreasing. If we're talking about the blue line, its perpendicular line would have to be decreasing because it's increasing, right? And its rise over run has to be inverted, right? It was rising 2 and running 3 before, so now, in order to be perpendicular, it has to be rising 3 and running 2. Does that make sense? So these are, I was thinking ahead of myself, perpendicular lines. All right, I may have covered this in other videos, but it's worth covering again, isn't it? Thank you for watching.